What about PSK?
Phase
Shift key.
shift.
Monil,
Yes, sir.
what is the difference between ASK and FSK?
સર ASK માં એમ્પ્લિટ્યુડ લેવલ કંઈક બતાવે અને FSK માં ફ્રીક્વન્સી નું લેવલ.
ફ્રીક્વન્સી નું લેવલ લેવલ ડિટેક્ટર હતા ભાઈ બી લેવલ ડિટેક્ટર હતા કે લેવલ દેખાડે
ના એટલે ડિસ્ક્રાઇબ કરે એમ.
ડિસ્ક્રાઇબ કરે હા હા okay anyone else what exactly the difference between ASK FSK and PSK yes Rahul what is it just tell me the difference between ASK and FSK Rahul present or should you will join afterwards
No, sir.
hmm
ASK and PSK na?
yeah ASK and I can't able to hear you Rahul yes
Hello. Sir, difference between ASK and
ASK
PSK?
and FSK
Sir, ASK uses variation in amplitude and FSK uses variation in
okay
frequency.
Ronak Ronak
Yes, sir.
what do you mean by variation in amplitude and variation in frequency?
એમ્પ્લિટ્યુડ ડિસ્ક્રીટ માટે બીટ વેલ્યુ અસાઇન કરે એ જ રીતે
Okay.
ફ્રીક્વન્સી.
First of all, you tell me that ASK and FSK and PSK the technique છે we use for conversion of analog to digital or digital to analog?
એનાલોગ ટુ ડિજિટલ.
Analog to digital. Mm-hmm. Rushi, we use it for analog to digital or digital to analog? According to the Ronak, he said analog to digital. Lucy, present? No, sir. Then what is the answer? Digital to analog. That's what Ronak told. મેં ખાલી ઊંધું કરીને કીધું હતું તને શાન
Yes, sir.
ASK, FSK, PSK techniques are used to convert analog to digital or digital to analog?
Analog to digital.
ઉમંગ
ડિજિટલ ટુ એનાલોગ.
ઇનપુટમાં આપણે શું આપી બધી ટેકનિકમાં in this technique what is the input we have umang in this technique what actually we have this is nothing but a digital to analog conversion in ASK here in the input we are giving the digital signals and output what we are getting according to the bit wise we are getting the variation in the frequency variation in the frequency that means digital માં કોઈ vary frequency હોય There will always be analog in outputs we have. So this all the techniques are being used to convert analog digital to analog signals. Yes, Parth. Parth. Okay. So am I audible, all of you? Margi. Margi. Are you online or should I remove from the meeting and you can join afterwards? Monil?
Yes, sir.
Okay, you are there. Where is the Yash Kalola?
Yes, sir.
Okay, yes. What do you mean by carrier frequency?
Carrier frequency is higher energy વાળું signal હોય એ carry કરે
Ah,
આગળ.
okay, why we always add the signal, carrier signals to our message signal?
Message signal energy ઓછી જોઈ ને વધારે.
હા, ઓછી જોઈએ કે વધારે જોઈએ એટલે શું કરવા માટે? Why we use signals to be added?
easy પડે જાવા signal.
Okay, that means if I want to send the message signal to the longer distance, I have to add the carrier signals to my message frequency. Okay,
Yes, sir.
that's why we add the. Okay, Shan,
Yes, sir.
what is the total phase we have in a what do you call PSK? What is the phase difference we have in the PSK? What is the phase difference we have in the PSK? Zero to 180 degree. Okay. Subham Trivedi Tripathi. Okay. 180 degree. Janice,
Yes, sir.
what actually happens when you transmit a bit 101 to the ASK? Yes. What happens when you transmit a digital signal 101 or any digital signal? How the signal looks like in ASK? What should be the change in ASK? For the bit 1, what I'll get, and for bit 0, what I'll get in ASK? Anyone?
Hello.
Yes.
1 હોય ત્યારે કેરિયર પ્રેઝન્ટ હોય અને 0 હોય ત્યારે કેરિયર એબસન્ટ હોય.
Okay, correct, Janice. What happens in a FSK? What happens if I have bit 1 and bit 0? What should be the output for FSK? Yes. Anyone? If I have bit 1 for the ASK, what the Janice told, that is correct. That means you can able to send the carrier at the bit 1, and you cannot have a carrier when the bit 0. What in the FSK? What happens if it is bit 1 is present and bit 0 is present? Yes, Parth.
सर 1 पे हाई फ्रिक्वेंसी होगी और 0 पे लो फ्रिक्वेंसी.
Correct. For this 1, you will get an high frequency, for 0 in the less frequency. Now in this today's session, we are going to implement and we are going to study about what is the ASK, FSK and PSK. Though we had done all the things, but still we are not had done the implementation of the circuit in a multi-sim. So today I am going to look at and explain you how the ASK and FSK and PSK can be implemented in a multi-sim circuit. So you know about this carrier frequency when you have. So in the last lecture, I think we had done in the multi-sim about the ASK. Okay, then also I'll just show you the circuit how we can able to do it in a ASK domain. So in the digital circuit, if you're talking about the frequency shift key, we have the carrier frequency, that is FC. So when you have a logic 1, your carrier frequency will add a delta F. And what this delta F stands for? The KF into V. Now, what do you mean by KF into V? V stands for voltage level. And this is nothing but a constant. So what happens? The voltage remains the same. But if you change this thing, that means this parameter is going to be changed. So it's a FC plus or minus delta. So at the frequency F1, it's FC plus delta. At the frequency 0, it's a FC minus delta F. That means here at the 1, if the frequency remains the same, for the 0, the KF value changes. That means your frequency value decreases. So we need to find a one parameter. See the voltage level, why it's a constant? Because the message signal have the constant amplitude. Okay, you had, yes, please.
Sir, screen is not visible.
Okay. Now it is visible?
Yes.
Okay. I'm talking about the frequency shift key. In a frequency shift key, when you have 1, you will get a high frequency signal. When you have the 0, you will get a low frequency signal. That means there is a change in the frequency only. What about the amplitude? Amplitude remains a constant. That means according to some inputs, I need what should be the frequency for logic 1 and logic 0. So for example, for the logic 1, at frequency f1, I can say it's nothing but your carrier frequency plus delta f. Now, what is the delta f means? It's nothing but a kf into V. Now, V stands for voltages. Here, the kf, that is a constant. Why we require the constant term over here? Because if you look the carrier frequency plus kf in the voltage. Now, how many terms are constant? The voltage is constant. Look at over here. The carrier frequency is also constant. Okay, from where we are applying the carrier frequency, that is also constant. So how I can able to increase or decrease the frequency, that should be depends upon your kf. Okay, so kf is one parameter which can able to help you to increase or decrease the frequency. So f1 helps to increase the frequency, where f2 at the logic 0 you must decrease. So it's fc minus delta f. So this is what the two different frequency I have, fc and fc, f1 and f2. Okay, when you do as a f1 minus f2, what the terms remains with you? Plus or minus 2 delta f only. Okay, the change in the frequency. So same way we had done the two digital codes. We have the binary 1 and binary 0. This is a high frequency. Again, this is a low frequency. You need to understand. So demonstration at a 2-point frequency. Today we are going to demonstrate a frequency shift keying, that how we can able to get a high frequency and the low frequency depends upon a signal. You know the binary frequency shift key. These are the things we had already done. What about the bandwidth? I told you the bandwidth in ASK, that is equal to bandwidth that is equal to S. That is a signal for signal. What the N stands for is nothing but a simple bit rate. But how many signals, the bits you are sending per second, that is what we call bit rate. So bandwidth of ASK is equal to the number of bits, because on the bits only you are getting the output. But in FSK is not that possible, because it's a frequency shift key. That means each and every bits you have some value. So here you have the bandwidth, that is depends upon a bit rate and also f1 minus f2. We had seen the values of f1, that is f1 is equal to fc plus delta f, and f2 that will be equal to fc minus delta f. So when you do the f1 minus f2 is nothing but a s plus 2 times a df, that is a delta f. This thing is clear, all of you? So this is what the difference between a bandwidth of ASK and the bandwidth of FSK. So now this is what your bandwidth equation for the FSK. There is a bandwidth D, again is totally depends upon a filter what you are using. Okay, so now for the basics, if they're not given in the questions, you will have to consider the D equal to 1. Otherwise, consider as the given value as for the question. Just wait for 2 minutes. Okay, all of you just solve this problem. All of you just solve this problem statement. What is the answer I'll get? Yes. Ethel joined at last and late, so you need to give the answer for this. Am I audible, all of you? Solve this problem and write down your answer in a chat box. Ethel, you had joined last, so you need to solve this problem. Yes, fast. Everything is given in the question itself. Just need to find out the bandwidth. What is the bandwidth of FSK, and just put it the answer. Everyone need to write answer in chat box. Yes, Subham. Monil. Yes. Umang. Rushi. I need answer. Which is the component you are not getting? Yes, Umang, it's audible. I'm audible. Umang,
Yes, sir.
આન્સર કેમ નથી આવતો? Find out the bandwidth. It's already been given. You need to find S. That is a sampling rate. That's all. Okay. It's a 50. What the 50 means? Answer. Umang, 50 means what? What should be the unit? It's a kbps. Good, Umang. That's what the answer. The 50 kbps. Okay. Now, next. We means it's a coherent and non-coherent. What do you mean by these two words? Because that is a very much important if we are taking an objective type exam. What do you mean by coherent and the non-coherent? In a non-coherent FSK scheme, when we change the one frequency to other, we do not change. Either means it's a kind of a word. It's similar to change of a current phase of a signal. In FSK, no need to change the frequency phase of a signal when you are jumping from one bit to another bit. But coherence means in a FSK, if you are switching from a one signal to another signals at the same phase in that signal. Okay, so in non-coherence, there is a change in the frequency. We do not change. We should change over here. That means in a non-coherence, when you jump from a one frequency to another frequency, like suppose this is the carrier frequency. If you need a slowest frequency, there is a change in the phase and then you will get an high frequency. Again, when you are going with a low frequency, change in the phase. Okay, this is what. So when you are jumping from a one frequency to another frequency, there is a change in the phase that we call as a non-coherence. But in coherence FSK, when you are jumping, it's a simple. Okay, so don't require any change in the phase. Now what we'll do, just it's okay everything. Now I'll just show you about the ASK circuit that we had done in the last lecture. Everyone, the screen is visible? The circuit is visible, everyone? Okay. So what we have to do in ASK depends upon the bit the carrier frequency will be present. So look at the function generator 1 and 2. I had selected one carrier frequency that is a 500 kilohertz and 50 kilohertz that is a digital signal. So what exactly I am doing, I am applying a one digital signal and another one that is nothing but a carrier frequency. Now in the transistor, according to transistor, this transistor gets on and off depends upon the logic 1 and logic 0. So function generator which have the digital signals I had given to the transistor. Now the output of the transistor I took as channel 1 and the channel 2 consists of carrier frequency and a channel 3 consists of, I'll just change this color to red. Okay, red is already there. That is changed to blue. Blue ponche, or let's suppose pink. Okay, so this pink color which shows that channel 2 is nothing but a carrier frequency. Blue color, that's what we see as a channel 3, that is a digital signal, what we had applied from a function generator. And now, why the transistor only had applied the input from a function generator 1? Why not from function generator 2? Anyone? What is the reason? So I had not applied the input from a function generator 2. What is the concept of a transistor? Anyone? Which is a transistor? Is common emitter, common base, or common collector? Yes, Ethel. A common emitter, common base, or common collector? Yes, Rushi. ટ્રાન્ઝિસ્ટરના કેટલા ઇનપુટ હોય ઋષિ? હલો ઉમંગ ઓડેબલ છે? Okay. So Dwarkesh, how many inputs we have in the transistor? Mahfuz, Dwarkesh, answer. How many inputs we have? ચાર. કયા કયા નામ બોલ બેટા? ચાર.
Three.
Three, but which are the three? Which are those threes? Which are those three inputs we have?
Base collector. Base collector.
Emitter, base, and collector. These are the three inputs we have. That means whenever the transistor is working as a switch, you know about that application of the transistor. It works as an amplifier or it works as a switch. So if the transistor is working as a switch, it needs some input. So this is what the input logic 1 and logic 0 I am giving to the transistor. Either it might be on or it might be off. So when you apply the input in a transistor in terms of square wave, if the transistor is on, it allows the VCC current to flow till this ground. And from there we will take an output to look at this. But if the transistor is getting off, none of the current will flow from the circuit and there will be a no current coming from VCC to ground. Due to this, the path has been blocked or the transistor is getting off. So when you run this, look at this. This is what the circuit we had seen. So what happens? Look at the pink color what we have. This is the carrier signals what we had applied. Okay, from a function generator 2. Now this carrier frequency multiplies with the logic what you had applied. So let's suppose that the logic 1 transistor gets on and all the carrier frequency will passes through the ground, and that is what the output we are getting as a carrier frequency. But when you apply the 0 from the function generator, the transistor gets off, none of the input received over here from this carrier frequency to over here. And this is how the transistor are working as a switch. So at 0, there is no output, no carrier frequency, 0 output. Again, when it wants, it will have a output of same as a carrier frequency. The thing is clear, the amplitude circuit. This is nothing but a simple ASK circuit we have. Now, let us move to the circuit we have, we call FSK. Okay, FSK is nothing but a two different frequency you must require. Okay, like F1 should be at a high frequency and F2 should be at low frequency. So what I took a two function generator, a three function generator, one where I'd applied 100 hertz, another that is a 500 hertz. Which is the faster frequency, F1 or F2? Which is the fastest frequency, F1 or F2? Yes, Ethel. Which is the highest frequency, the F1 or F2? Yes. So 500 hertz is the fastest frequency compared to the 100 hertz. Fine. I had given that input F1 and F2 to the multiplexer block. Now, what is the job of a multiplexer? Here, the circuit. What is the job of a multiplexer? I had given a one slow frequency and one the high frequency with the same amplitude, okay, to the multiplexer block. Now, if you look at the multiplexer block, as in the digital electronics we had studied, the A and B, there should be a one selection line, and that is a Y. So, if the selection line is 0, A will go to the output, and if the selection line is 1, the B will go to the output. That is what the job of a multiplexer. Now here, applying 0 and 1 in the selection line, that is possible using which waveforms? That is nothing but a digital waveforms. So what I am doing, I am taking a third function generator. In that I had applied a digital inputs 1 and 0. And that inputs, these digital inputs, I had applied to the selection line of a multiplexer. So if it is 0, it will pass this function generator to the oscilloscope, and if it is 1, this function generator will pass to the oscilloscope. So simple circuit I had this design. So if I run this as a program, and look at over here, is this the waveforms we are looking for? Is this the waveform we are looking for? Is this the waveform we are looking for? Okay, let it be the auto. Yes. This is the waveform we are getting. At the one, we are getting a high bit rate. At though we had given the sinusoidal signal as the input, but you are getting a digital signal. Why? This is the circuit we are looking for. Yes, Subham, Dwarkesh. Yes, Dwarkesh. Write down the answer.
No,
What
sir.
actually we are looking for? If it is no, then what should be the circuit should come at last? I need an answer from each and every student. Ghanshyam, write down the answer. Each and every student should write the answer. If it is no, why should it no? Analog? What do you mean by analog, Dwarkesh? Yes, Ghanshyam. Hital, Jay, write down your answer. I don't want that answer. That means multisim shows the circuit that is a correct circuit or a wrong circuit. If you are not writing answer, I am not going to make another correct circuit for you. चलो आंसर नहीं लखो ત્યાં સુધી તો અટેન્ડન્સ નહીં આપવું આજની. Only Dwarkesh wrote the answer. What about the rest of the students? Let's wait for a few minutes. Let's see. Monil, your answer should not be so specific. Okay, write down in the words. We want analog signal as the output, not digital signal. Okay. And tell me the reason that why we got the digital output. All of you. What is the reason to get a digital output? मैं तो आईपू तो the sinusoidal waveform है. Have the circuit in front of you. From the both the function generator, I had given a 100 hertz and the 500 hertz. Then also we got an output as a digital signal. How it is possible? I'd use only multiplexer and two function generator, that's all. That's okay. I understood that. Okay, we need an analog signal. But in this circuit, I had just applied only sinusoidal signals and the sine wave, square wave, but still I'm getting a digital signal. Many of the students have still not given the answer. They need to give that answer. We'll take a break of 10 minutes. Those who have given the answer for this last mavra digital joy, analog signal joy, one digital malaise, they don't have to give the answer. For the rest of the students, I need an answer that why we got a digital signals though we had applied analog signal in the circuit. We'll meet you after, we'll meet at 1:05. Is that okay? Till that, rest of the students find the answer. The circuit is in front of you. Okay, good afternoon again. Well back. Dwarkesh?
Yes,
Dwarkesh?
sir.
Hital?
Yes, sir.
Hital? Okay, Jai? Undani? Chenis?
Yes, sir.
Margi?
Yes, sir.
Mehfooz?
Yes, sir.
Monil?
Yes, sir.
Rahul? Ronak?
Yes, sir.
Rushi?
Yes, sir.
Shan?
Yes, sir.
Shubham?
Yes, sir.
Umang?
Yes, sir.
Okay. Now, did anyone get the answer that why we got a digital data, though we had applied an analog signal? Anyone? It's very easy. Just you need to understand your common sense. Or though you already studied about the DCN, digital electronics. Anyone? Okay. If I'll ask you one thing, the multiplexer is a block of analog or digital? Good, Shan. From wherever you found the answer or how you depends upon your common sense. If you give the answer, it's a very good answer you had given to the question. Hey, Shan, good, very good. Multiplexers always gives the output in terms of digital because it's a digital block. It can only accept or reject the data based on the digital format only. So that is what the reason we had got the output in terms of digital. Now, let us then this circuit we cannot able to implement it. The reason is due to this problem. Now what we can do, we try to use a different block. This is what the block name we call is nothing but it's I'll just present the circuit. Okay, so this is the circuit what exactly we are getting a digital output, and we'll move towards this block diagram. So this is nothing but a simple multiplexer circuit. But actually, if you look at the digital or a analog FSK circuit, it should look like this. This is a cross indicating there are nothing but a simple multipliers. So there are the two oscillators we call as a carrier frequency generator because we need to generate the two frequency. One is the highest frequency, one is the lowest frequency. So you must require the two carrier frequency. So this is the oscillator F1, oscillator F2. One digital input which have signal, at that particular signals F1 only will multiply. The rest of this, if I want to get inverted signal of this bit, that should be this one. So I must require a NOT gate from where the digital inputs have inverted and applied to the another, and there I'll multiply this thing. So I wanna say there you will get a higher frequency. Wherever you have the low, you will get a lower frequency. This is what we need to do. So we need to separate out these two digital signals. So one binary input which is coming, I'm directly giving to the first F1 and another is a F2. And then at last, I'm doing the sum. Look at over here. This is what the output of this multiplier and this is what the output of this multiplier. So when you combine these two together, it will make you a FSK circuit. So for that, I just need to implement this circuit. until I just implement, think about that what exactly you had done in this circuit. Okay, just I'll make the circuit in a multisim. Okay, the screen is visible, all of you. Is the screen is visible? Multisim circuit. Okay, so what I took multiplier. Okay, this is the block of a multiplier. It's not a multiplexer, it's a multiplier. So what I need first, I need a function generator to generate a oscilloscope, to generate a digital signal. Okay, a function generator. I need to generate a signal of, let's suppose, 100 hertz, and that is a digital signal. So one signal I have to give as a input 1, and another signal should I have to give to the input 2. But I cannot able to directly connect this circuit to here because the same input I don't want. What exactly I need to connect? I have to connect AND gate. So I'll take it the AND gate from here, the logic gates. So go to the TTL, the NOT gate. So now ideal diode. Okay, go to this yes, binary digital TTL NOT gate. I need a NOT gate, so I'll write it over here NOT. So I got a NOT gate. So connect here. One of the NOT gate input will go over here, and another input will go over here. So what exactly I'm doing? So at it side by side, we'll also look at in the wave oscilloscope also that what exactly we are giving. I don't want that simple oscilloscope, 2-channel oscilloscope I must require. Okay, this one. So what I am giving, one input from here, another input from here. So let's look what actually we are giving. I'll just change the color so that it will be easy to represent. Let it be blue. So now, okay. Reverse. Just two different. See here. So what exactly we are doing? Let it be 5. So here, these signals are opposite to each other. So when this signals goes to 0, this signals will be 1. So when this will be 1, this will be 0. Those two inverted signal I had applied to the analog block. Okay. So what now the next we need to do? We need to take a two different frequencies. So function generator 1, a sine wave. Let us take a 100 hertz frequency and apply that. So whenever you will get a 1 with this, 100 hertz will multiply. I need another function generator. I need another function generator to generate a different frequency we call 500 hertz, and that should be sinusoidal, and that is applied to the source too. So three of the function generators have been applied, 1 and 2. Does we need anything else? I must need ground. Okay, so what I will do, just delete this. I'll put an oscilloscope here to watch the output. What exactly the output we are getting from here. And this A should be connected to the ground. This is also a ground, and this function generator is also connected to a ground, and I must have a ground. Okay, this is what the circuit is the same. So this function generator will generate a digital signal. This too will generate a different oscillator signal. Now everything is completed. Nothing is to be just an oscilloscope. Okay, another channel will connect to the digital signal. So what we are applying, and this should be connected to again a ground. Let's run. See now, you can able to see the different frequencies what we had applied. I'll just take digital signal. Yeah, the frequency amplitude should be reduced and should be sent upward. Okay, this should go to the down. This is too high frequency. Just what I'll do, just I'll make this as a 200. Let it be 500. Fine. Okay, so you can see over here is what the complete circuit of an FSK. Here for the high frequency I'd consider the logic 0, but if you connect your output to the inverter circuit, you will get your circuit. This thing is clear, all of you? Now compared to that circuit, the circuit will give you more brief introduction about what we had done. Any doubt in this circuit? I'm still waiting over here for any question. Any doubt? Shubham, is it clear? The circuit is Parkesh. So this is what actually by today's session we need to do about the circuit. The same circuit what we had done according to this diagram. Okay, this is what the diagram you had seen. So by today's, that's all we need to do. Again, I'm asking the questions that I had put the marks, though I'm asking how many students had not completed the week 3. In a Coursera. I didn't complete, half remains. Though I already put the marks, Shubham. Okay. If you want to complete it, do it fast. Otherwise, it's okay. You didn't get the marks for this. Those who had completed in the third week, if you had completed less modules, based on that, I had given the marks to you. So at last, the total marks will be calculated according to the week wise we are doing. So now, those who are not completed, do it right now. So I already given the marks, but in the next Sunday, the target is to complete the week 4. With the course is of total 5 weeks. So just 2 weeks are remaining. To complete the week, possibilities of 4 at the end of this Sunday. Again, the Monday for the week 4 also I'll putting the marks. So when you submit the session, on that particular week only I need a certificate to be uploaded. Particular date I will say. If you didn't upload on that day, I cannot able to give you the marks. That is the 20 marks for when you submit the your Coursera certificate. Okay, after the week 5. So if you're not doing, I don't have any problem. Let it be. Okay. So still half an hour is there. What exactly you can able to do it? I'll give you some task to do. There is a one link. I had sent you the link. Okay, what the circuit we had implement. Based on that, all the things had been mentioned on the link. Let's have a look and study the practical, what we had performed. Okay, for 10 to 15 minutes, just study about the practical, what we had done. The same circuit, what we had done in the multi-sim, they had implemented over there. There's electronics for you. Still, if anyone have a doubt, I am sitting over here. Go to the link and might be they have some virtual lab also. You can perform the practical, but I don't think so. You can just study that practical what we had done the experiment right now. Study practical, and if you have a doubt in this practical, I'm here to ask any question. Done all of you reading? Okay, once you are done, just write down the enrollment number from a computer department first. All are from C. Hello. Start the first computer number. Okay. Complete all the things on it.
Sir, CE80.
Who
CE80.
is that? What is your name?
Rahul Orendra, sir. લખાઈ ગયું હવે. Recent output. હવે લખાઈ.
Okay. So again, I am telling complete Coursera on a time. If you didn't complete on a time, you will not get a good marks at last. Okay. Fine, then those who had written the attendance, they can leave. Ghanshyam, completed?